Inshallah, in today's class, we are going to discuss about the canonical form by orthogonal transformation, reducing the matrix to canonical form by orthogonal transformation. First, let me see the steps how to change. So in first step, write the symmetric matrix A. How we will do, let me see in the example. Just remember the method. And the second step is find the eigenvalues. Third step is find the eigenvectors. And step 4 is write the normalized model matrix. We already done this in the previous classes. Normalized model matrix is x1 by mod x1, x2 by mod x2, x3 by mod x3. Now the diagonal matrix is given by D equals to P transpose into A into P. Now the canonical form can be written as lambda 1 y1 square plus lambda 2 y2 square plus lambda 3 y3 square with linear transformation x equals to py. With linear transformation x equals to py. You just write all these steps and you just revise this. Inshallah, we will do one question on based on this form steps. Now see the question. Reduce the quadratic form by orthogonal reduction. Reduce the quadratic form to canonical form. To canonical form by orthogonal reduction method. We call this like this also, sum of the squares. Sum of the squares form. Sum of the squares form is also same, that is canonical form. So let me change this into matrix. We already know this method. We discussed this in the previous class. Okay, what are the variables? X, Y, Z. So write X, Y, Z. Here also you write X, Y, Z. Now X square coefficient is 3, so it will be 3 here. Here Y square coefficient 5, Z square coefficient 3. Now see here, this is XY, this is also XY, XY, XY. So XY coefficient is -2. We have to reduce to half. -2 by 2 will be -1. This should be half. -1, -1. Now here XZ. XZ is also 2, so write 1. Reduce to this by 2, half. Now lastly this one, this is my YZ. So here is YZ, here is YZ. -1, -1. Okay. These three terms will reduce to half. Therefore, let we denote this by A. A equals to 3 -1 1 -1 5 -1 1 -1 3. So now this is the symmetric matrix, step 1. Now step 2, we have to find eigenvalues. For that we write characteristic equation. The characteristic equation is, what is the formula? A minus mod I equals to 0. Mod of A minus lambda equals to 0. We already know how to change this. Okay, so let me change this one. 3 minus lambda -1 1 -1 5 minus lambda -1 1 -1 3 minus lambda equals to 0. What we did with this diagonal elements, we apply minus lambda. 3 minus lambda, 5 minus lambda, 3 minus lambda, remaining as it is. Now let me expand this. This is the determinant. Let me expand 3 minus lambda into, hide this one, multiply this 2 minus this 2. So this will be 5 minus lambda into 3 minus lambda minus written as +1. You have to change the sign of this -1 now, so write +1. Now hide this, -1 into 3 minus lambda minus 1 into -1 -1. Again minus means this will be +1 +1 into, now lastly this one, if you take 1 you hide this, minus it as 1 -1 into 5 minus lambda equals to 0. So now let me solve this one. 3 minus lambda into, now multiply this one, multiply this one. This will be, first I am writing lambda square, minus into minus plus, lambda into lambda, lambda square You see 5 into minus lambda minus 5 lambda minus 3 lambda will be minus 8 lambda. So 5 3s are 15 minus 1 14 plus 14 plus 1 into minus into minus plus lambda minus 3 plus 1 minus 2 plus 1 into minus into minus plus lambda minus 5 plus 1 will be minus 4 equals to 0. Now you multiply with 3. 3 into lambda square is 3 lambda square minus 3 8 is 24 lambda 3 14 is 42. 3 lambda square 3 8 is 24 lambda plus 3 14 is 42 minus into plus minus lambda cube minus into minus plus 8 lambda square minus into plus minus 14 lambda, then here minus lambda cube minus minus plus 8 lambda square minus 14 lambda plus lambda minus 2 plus lambda minus 4 equals to 0. Now the first step is minus lambda cube. Now square terms 8 plus 3 11 11 lambda square. Now minus 24 lambda plus lambda 2 2 minus 14 minus 12 minus 12 and minus 24 34 36 minus 36 lambda. Lastly constants 48 sorry 42 minus 6 plus 36 equals to 0. Now take minus common from here. If you take minus common, this will be lambda cube minus 11 lambda square plus 36 lambda minus 36 equals to 0. This is the cubic equation. So if we have cubic equation, we can solve this by calci. So how to take the calci? First you take mode. We want equations is number 5, so take equations. Now fourth one is the cubic equation, take 4, number 4. Now apply the coefficients. First one is 1 equals to minus 11 equals to 36 equals to minus 36. So we'll get the values. The values are lambda equals to 632,236. So first second step is finished. We have got the eigenvalues. Now let me find the eigenvectors. Now see here, to find the vectors we use a minus lambda into x equals to 0. A minus lambda, I already written this one, into x is x1 x2 x3 equals to 0. First we take lambda equals to, let me take lambda equals to 2. We are having three values, lambda equals to 2 3 6 1 after 1. Let me substitute. First if we keep lambda equals to 2, this will be 3 minus 2 1 minus 1 1 minus 1. 5 minus 2 will be 3 minus 1 1 minus 1. 3 minus 2 will be 1 into x1 x2 x3 equals to 0. Now if we multiply, we'll get the equations. 1 into x1 x1 minus x2 plus x3 equals to 0. Now here minus x1 plus 3x2 minus x3 equals to 0. And third one is x1 minus x2 plus x3 equals to 0. Let me solve this too. We already know how to solve. Start from the middle. Minus 1 1 1 minus 1. Start from here. Minus 1 1 1 minus 1 minus 1 1 1 minus 1. Here is 3 minus 1 minus 1 3. 3 minus 1 minus 1 3. Here x1 x2 x3. So x1 divided by minus 2 minus plus 1 1 minus 3 1 minus 3 minus 2. x2 divided by minus 1 minus 1 is plus 1 0 equals to x3 divided by 3 minus 1 is 2. We can cancel this 2 ones are 2 ones are. Therefore we go to the first vector minus 1 0 1 minus 1 0 1. Now let me take the case 2 for lambda equals to 3. See here, if we keep lambda equals to 3, 3 minus 3 will be 0, minus 1, 1, minus 1. 5 minus 3 will be 2, minus 1, 1, minus 1. 3 minus 3 will be 0 into, now let me solve this one, x1, x2, x3. x1, x2, x3 equals to 0. Now so multiply this one, 0 into x1, 0 x1 minus x2 plus x3 equals to 0. Now minus x1 plus 2x2 minus x3 equals to 0. Lastly, x1 minus x2 plus 0 x3 equals to 0. Let me solve this one, minus 1, 1, 0, minus 1. Minus 1, 1, 0, minus 1. Here 2 minus 1 minus 1, 2. 2 minus 1 minus 1, 2. Now take here x1, x2, x3. So x1 divided by minus 1 is 1. 1 minus 2 minus 1 equals to x2 divided by minus 1. Minus 0 will be minus 1. x3 divided by 0 minus 1 minus 1. 1 minus 2 minus 1 minus 1 minus 0 minus 1 0 minus 1. You can cancel this minus minus minus. So we get the second vector as 1 1 1. Therefore x2 equals to 1 1 1. Now the case 3, third vector for lambda equals to 6. If we keep 6, 3 minus 6 will be minus 3 minus 1 1 minus 1. 5 minus 6 will be minus 1 minus 1 1 minus 1. 3 minus 6 will be minus 3 into x1, x2, x3 equals to 0. Now if we solve this one, we will get one third vector. Multiply this, minus 3x1 minus x2 plus x3 equals to 0. Let me take minus common here. If we take minus common, it will become plus. So x1 plus x2 plus x3 equals to, because all three are minus, I am taking minus common here, so it will become plus. So the lastly is x1 minus x2 minus 3x3 equals to 0. Now let us solve this to minus 1 1 minus 3 minus 1 minus 1 1 minus 3 minus 1. Here is 1 1 1 1. So x1, x2, x3. So x1 divided by minus 1 minus 1 minus 2. x2 divided by 1 minus 1 is plus 3 is 4 equals to x3 divided by minus 3 minus 1 is, see here, x3 divided by minus 3 minus 1 is plus 1 minus 3 plus 1 minus 2. We can cancel 2 ones are 2 twos are 2 ones are. Take minus common, this will become plus, this will become minus, this will become plus. So x1 by 1 equals to x2 by minus 2 equals to x3 by minus 1. Therefore this is the third vector is 1 minus 2 1 minus 2 1. We have taken minus common, no? So this is the third vector. Now the next step is we have to find the normalized model matrix. Now we got the values of x1, x2, x3. Now let me find mod of x1. Mod of x1 is under root of squares of this. So minus 1 square plus 0 square plus 1 square equals to under root of 1 plus 1, 2. Similarly, let me find the mod x2. Mod x2 equals to under root of 1 plus 1 plus 1. So it is root 3. Here also write mod x3 under root of 1 plus minus 2 square 4 plus 1. So this is root 6. Now we are having model matrices. Model matrices x1, x2, x3. So you get x1 is this one, minus 1, 0, 1. x2 is 1 1 1, x3 is 1 minus 2 1. This is normal matrix. No, sorry, model matrix. Now we have to find normalized model matrix. So normalized model matrix is P equals to x1 by mod x1, x2 by mod x2, x3 by mod x3. This is normalized model matrix. So let we divide x1 by mod x1. We have to divide this mod by mod x1 minus 1 by root 2, 0 by number 0, 1 by root 2. Now for this we have to divide by root 3, 1 by root 3, 1 by root 3, 1 by root 3. This is the value of P. Now next one is 1 by root 6, this one minus 2 by root 6, 1 by root 6. So this is the normalized model matrix. Now we know what is the value of D. Now next step is we are having diagonal matrix D equals to P transpose into A into P. P transpose into A into P. Now let me write the value equals to D equals to P transposes this one. So this will be minus 1 by root 2, 1 by 0, 1 by root transpose of this 1 by root 3, 1 by root 3, 1 by root 3. We change this column to row. 1 by root 6 minus 2 by root 6 into 1 by root 6. This is P transpose. Now into A. A is the given matrix. So given matrix is 3 minus 1, 1, minus 1, 5, 1, minus 1, 1 minus 1, 3. Into P. The value of P is here 1 minus 1 by root 2, 1 by root 3, 1 by root 6, 0, 1 by root 3 minus 2 by root 6. The last is 1 by root 2, 1 by root 2, 1 by root 3, 1 by root 6. So if you multiply this, what we get, we already discussed this in the previous classes, we'll get the eigenvalues in the diagonal. The remaining will be 0. The first eigenvalue we substitute is 2, 0, 0, 0. The second value is 3, 0, 0, 0. This value is 6. So we get 2, comma, 0, comma, 0, comma. So this is the diagonal matrix. Now therefore canonical form. When we say canonical form, you apply with this y1 square, y2 square, y3 square. It will be 2y1 square plus 3y2 square plus 6y3 square. First step. With this you also write the linear transformation, where linear transformation is x equals to p into y. Now substitute the values. X means we have variables, we are having x, y, z as variables, equals to p. We already find the value of p. P is minus 1 by root 2, 1 by root 3, 1 by root 6, 0, 1 by root 3 minus 2 by root 6, and lastly is 1 by root 2, 1 by root 3, 1 by root 6 into y. Y is y1, y2, y3. So after writing the canonical form, you write the linear transformation. Linear transformation is x equals to p into y. X equals to p into y. So this is the method of reducing to canonical form by orthogonal reduction method.